In this video, I'm going to talk about reciprocal functions. The reciprocal function of y equals to fx is y equals to 1 over fx. Now, let me show you how to graph a reciprocal function. Function x equals to x squared plus 2x minus 3. In this case, the reciprocal function would be 1 over x squared plus 2x minus 3. In order to sketch the reciprocal function, we first need to sketch the original function. For the x-intercept of x squared plus 2x minus 3, y equals to 0, x squared plus 2x minus 3 equals to x plus 3 times x minus 1. So the x-intercept would be negative 3 and 1. So we can mark it on the axis. And for y-intercept, x equals to 0, so the y-intercept is negative 3. We can also mark that on the y-axis. With all that information, we can draw a parabola like this. And the axis of symmetry is x equals to negative 1, which is halfway between the x-intercepts. So function negative 1 equals to negative 4. So the vertex is negative 1, negative 4. Okay, now we can use the graph to sketch the reciprocal graph. Okay, first, when fx equals to 0, in this case, x equals to negative 3 and negative 1. And since 0 cannot be the denominator, the function is undefined when x equals to negative 3 and negative 1. So we can draw two vertical asymptotes. Okay, now let's look at the behavior of the graph. As the x value is going towards the negative infinity, the y value is going towards the x infinity. Apart from that, when the x value is going towards the infinite, the y value is also going towards the infinite. Now let's look at the behavior near the asymptotes. As x approaches to negative 3, the y value becomes small but always bigger than 0. So the reciprocal graph near x equals to negative 3 would be large and also bigger than 0. When the x value approaches to negative 3 on the right side, the value will be smaller than 0 but become larger. So the reciprocal function is going to be smaller when it approaches to negative 3 from the right side. Similarly to 1, when the x value is approaching to 1 from the left side, the reciprocal function is going to be smaller. On the other hand, it's going to be bigger. Okay, now we've looked at the behavior, let's look at into more detail. So the vertex of the parabola is negative 1 and negative 4. So the corresponding point on the reciprocal function would be negative 1 and negative 1 over 4 as the vertex. Apart from that, the y-intercept of the function is negative 3. So the y-intercept of the reciprocal function would be negative 1 over 3. So it will be right here. And as the value of function x increases, the value of 1 over function x decreases, and vice versa. This means that where the function has a minimum turning point, the reciprocal function will have a maximum turning point like this. With all that information, we can construct a graph like this, and these are its domain and range. Okay, now let me show you the properties of reciprocal functions. First, as function x increases, the reciprocal function decreases. Vice versa. Second, as a function approaches to negative or positive infinity, then the reciprocal function approaches to 0. Thirdly, where the graph of y equals to function x has x-intercepts, the graph of y equals to 1 over function x will have vertical asymptotes at these x values. Next up, if y equals to function x has vertex a, b, then the reciprocal function will have vertex at a and 1 over b. Last but not least, if y equals to function x has a maximum or minimum turning point, then its reciprocal function will have an opposite turning point at the same x value. Okay, that's all for today. I'll see you next time.